In our last lecture we were talking about exponents, and I gave you some laws of exponents. I gave you 6 of them, laws of exponents. We're going to extend it a little bit today. Yeah, oh, I forgot. You have any questions about the problems I assigned to you? I believe they were on page 140, is that right?
Yes.
And I gave you, what, 1 through 42?
Right.
Are there any there that you'd like to see worked?
42.
42? Okay. In number 42. Let's see. Okay, if you do that correctly, I believe you come out with a positive answer. Is that correct? And I think it's the arithmetic more than anything else that threw you. I think it came out to be 512. And the denominator, I think it's what, 21? 87.
Okay.
And then the rest of the algebra are trivial. It was the arithmetic that threw most students. You had 2 raised to all those powers and 3 raised to the powers. Okay, let's go on. Let's suppose we have x to the 3rd divided by x to the 3rd. What is x to the 3rd divided by x to the 3rd? Jan?
1.
1. Because we learned long ago, maybe 2nd grade, that anything divided by itself is always 1. So this is a 1. Let's suppose I have x to the 3rd divided by x to the 3rd again. But this time, I'm going to use my rule of exponents. The rules of exponents is anytime you divide like bases, keep the base. And what do you do with the exponents? Subtract them. Well, if I subtract, what do I get? X to the 0. Now notice, they are both equal to the same quantity. 1 is equal to x cubed over x cubed. X to the 0 is equal to x cubed over x cubed. So what logical statement follows? X to the 0 is equal to 1. And this is our 7th property dealing with exponents. X to the 0 is equal to 1. This is anything, with the exception of 0, raised to the 0 power is equal to 1. Anything raised to the 0 power is 1. In other words, if I have 5 to the 0 power, Wong, what's that going to equal?
It's 1.
1, sure. Very good, Wong. Give you another one. Suppose I have 5x to the 0 power.
It's 1s.
What is it going to equal?
It's 1s.
Nope. Nope. Tony?
5.
5. What's being raised to the 0 power?
S.
Just
Yeah.
the x.
Okay.
So this becomes 5 times 1, which is 5. Let's suppose I have 5x, the quantity, raised to the 0 power. 5x, the quantity, raised to the 0 power. What's that equal to, Wong?
5s.
Nope. 1.
1.
1. This is 1. Now you see this 5 is to the 1st power, x is to the 1st power. So if you use our rules of exponents, we have 5, 1 times 0, 0. We have x, 1 times 0, 0. But 5 to the 0 is 1. X to the 0 is 1. We come out with 1 times 1, which is 1. So remember that, very important. What we have done here, we have introduced a new exponent, one we never had before, 0. All our exponents before were always positive whole numbers. Now we have a brand new one, 0. Now, let's suppose I have x to the 3rd divided by x to the 5th. X to the 3rd divided by x to the 5th. What would that equal? Help. Tony?
1 over x squared.
1 over x squared. That's by property 3. Property 3 says, hey, anytime you divide like exponents, and the largest exponent is in the denominator, your base is going to end up in the denominator. You subtract the exponents. Let's take that same problem. And let's suppose we only have property 2. Property 2 says anytime you divide like bases, you keep the base and you subtract the exponents. So we get x to what? Negative 2. Look. Hey, they're both equal to the same quantity. So they have to equal each other. In other words, x to the negative 2 is equal to 1 over x squared. More generally, x to the negative n power is equal to 1 over x to the positive n power. All we're saying here is anytime you have a base that has a negative exponent, if you want to get rid of that negative exponent, you write the reciprocal of the base. That means 1 over the base. And make the exponents positive. Okay? Suppose I have, let's see, a to the negative 8th power. And I asked you to express this without negative exponents. What would a to the negative 8th power be? Jan?
1 over a to the 8.
1 over a to the 8th. Very good, Jan. 1 over a to the 8th. That's what the property says. Okay? Well, let's show you some arithmetic problems. Suppose we have 3 to the negative 1 power. And I asked you to express this in simplified form without negative exponents. What would 3 to the negative 1 power equal? Tony?
1/3.
1/3. 1 over 3 raised to the positive 1, which is 1/3. Okay? What if we have 7 to the negative 2 power? 7 to the negative 2 power. And I ask you to write this in simplified form without negative exponent. What would that equal? Help. Wong?
1 over 7 square.
Or?
Or 1 over 49.
Very good. 1 over 49. Okay? See, nice and easy it is. They're not all nice and easy, though. Suppose we have, well, let's see, 5 over 2 to the negative 3 power. See if we can express this without negative exponents in simplified form. Okay. Who has something? Jen, do you have something? What do you have?
5 over 1/8.
5 over 1/8? Yeah, but that's not in simplified form yet. That's right what you have, but you're not done yet. Help. 40. But very good, Jan. You had to start. You had the hardest part done. Here we go. What we have to do is write this without negative exponents. So we have 5 over. We have 2 to the negative 3 power. Well, we said anytime we have a negative exponent, to get rid of it, we write the reciprocal. That means 1 over it. So that'd be 1 over 2 cubed. What we have here, Jan, is called a complex fraction. This is what you just got done working. This is 5 divided by 1 over 2 cubed, which is 8. Well, how do we divide by a fraction? We invert, multiply. So we have 5 times 8 over 1, which was 40. Yes?
How come you kept it as a complex fraction instead of just taking it 2 cubed?
You're going to run into trouble that way, Tony. Run into a lot of trouble.
Okay.
Okay? What's that do to eraser?
Under the blue one.
Oh, I never find it. Okay. Suppose we have 3 to the negative 1 over 7 to the negative 1. Okay, babe, you get an answer?
7 over 3.
7 over 3 is correct. The way we get this, we want to get rid of negative exponents. We have 3 to the negative 1, that's 1 over 3. We have all over, we have 7 to the negative 1, which is 1 over 7. So what we have is 1/3 divided by 1/7, which is equal to 1/3 times 7 over 1. And multiply the tops, multiply the bottom. Now, Tony asked me if you have a negative exponent, can you just move it in the opposite place, make the exponent positive? In other words, if it's negative and it's in the numerator, make it positive, put it in the denominator, and if it's negative in the denominator, move it in the numerator, make it positive. That will work today. But it's not going to work on Monday. It's like, remember when we first factored 3 termers, Tony, and the last sign was negative. Well, you could either change if you factored it and you got the wrong sign, you could either change the numbers or the signs. But I told you, changing the numbers will only work that day, and when we get something else, it's not going to work. Well, the same thing holds true here. It works today, but I want to give you something that always works. So you have an understanding of what's happening, okay? Six to the negative 1 plus 6 to the 0. What do we get for the answer here? Wrong?
7 over 6.
7 6?
Yeah.
Or
Or
1 and 1/6?
yeah.
Yeah, either way. I like 7 6 better. I like your first answer. Here we go. We want to simplify this. So first of all, we have 6 to the negative 1. That becomes 1/6. Plus 6 to the 0. Well, we know that anything to the 0 power is 1. So what we have is 1 6 plus 1. LCD is 6. U1 plus 6, which is equal to 7 6. And there's the answer. Okay? Let's try this one. 3 to the negative 1 plus 3 to the negative 2. Okay, as you can see, this is more arithmetic and algebra. I believe the answer comes out to be 4/9. 4/9. How we get it? Well, the first thing we're going to have to do is get rid of negative exponents. So we have 1 over 3 plus 1 over 3 squared. The negative exponents are gone by property 8. So now we have 1/3 plus 1/9. Well, what we have to do is find an LCD. That's arithmetic. The LCD is 9. That means we're going to have to multiply this first denominator by 3, multiply the numerator by 3. Second denominator, we don't have to do anything to that. Don't do anything to the numerator. And we come out with 4/9. Okay? This next group of problems I'd like you to write as a single fraction in simplified form without negative exponents. That's the direction. A cubed, b to the negative 4th. I'd like you to write that as a single fraction in simplified form without negative exponents. Okay, this shouldn't take long. It should take a matter of seconds. We want to express this as a single fraction without negative exponents. So the first thing we're going to do is get rid of negative exponents. Well, our a is raised to positive, we leave it alone. Times. Well, that has a negative exponent. Well, b to the negative 4th is nothing but 1 over b to the 4th. Remember, a cubed is understood to be over 1. This is what we got. We're rid of negative exponents. We now have to write this as a single fraction. If we do, we have a to the 3rd over b to the 4th. That's it. Same instructions. X to the negative 1, y squared, z to the negative 3. I'd like you to write that as a single fraction without negative exponents. Jan, what'd you get?
Y squared over x times z to the 3rd.
Sure. That's it. That's it. How we get it? Well, we want to get rid of those terms that have factors that have negative exponents. Get rid of the negative. We have 1 over x to the 1st. Y, hey, that's okay. So we have y squared over 1. z to the negative 3. We write this without negative exponents, we get 1 over z to the positive 3. So there we got rid of all the negative exponents. It's now a multiplication problem. If we multiply the numerators, we get y squared. Multiply the denominators, we have x, z, cubed. Okay? Suppose we have 5x to the negative 1. And again, I asked you to express that as a single fraction without negative exponents. Tony, what you get?
5 over x.
Very good. The most common mistake students make here is they'll put the whole thing over 1. They'll write 1 over 5x. Only the x has the negative exponent. So we want to get rid of negative exponents. We have 5 times x to the negative 1 becomes 1 over x to the positive 1, which is 5 over x, as Tony says. Very good. Very good. Let's suppose we have this. X to the 9th times x to the negative 4th. Okay, everybody's finished. BB, what you get for an answer?
X to the F.
X to the...
Negative 4. I got negative 1.
Oh, okay, negative 4. See how that affects your answer.
X to the 5th.
X to the 5th. I agree. That's the right answer. How'd you get it, Beeb? How'd you do it?
X to the 9 multiplied by 1 over x to the 4th.
Oh, she got to multiply by 1 over x to the 4th. Okay?
And then
Did all that? Okay, Beeb, I know what you did. I know exactly what you did. She went x to the 9th times 1 over x to the 4th, multiply. Okay. What I'd like you to do is I'd like you to turn back to the lecture we had on Tuesday. Go, remember those 6 properties I gave you? Turn back there, Beeb. Can you find them someplace? Those 6 properties? Yeah? Oh, you have them right there, right? What does property 1 say? Property 1. What's it say?
x to the a times x to the b equals to x to the a plus b.
Very good. Look what we're doing. We're multiplying. And we said property 1 says anytime you multiply the like bases, you keep the base, you add the exponents. You had no trouble adding sign numbers. 9 and a negative 4 is a positive. Yours was right, Beeb. But you went through a lot of work for it. Remember, the laws of exponents. Told you we're going to get a lot of different things up here for exponents. The laws don't change, though. Anytime you multiply like bases, you keep the base, you add the exponent. So let's suppose we have a to the 5th times a to the negative 1 times a to the negative 6 times a to the 4th. What do we get there? Okay, what do you get for an answer? Wong?
A to the square.
A squared. I like the way Bibi did this problem. Very nice form. What she did is she said, hey, they're all the same base, so we're going to end up with A, and we're going to add the exponents. So she has 5, negative 1, negative 6, positive 4. That's what it says to do. Now, I know most of you add these up mentally as you went through, but this is good procedure. We add these up, we get A squared. Okay? Let's suppose we have x to the 5th divided by x to the negative 2 power. Long?
X to the 7.
Very good. X to the 7th. And again, we use Beebe's principle. We're not going to make careless mistakes. Anytime we divide like bases, different exponents, we keep the base. And what do we do with the exponents? We subtract. The word subtract means add the opposite. So we have a 5. The opposite of negative 2 becomes a positive 2. So we have x to the 7. Okay? Let's suppose we have x to the negative 3 raised to the negative 4 power. One,
X to the 12.
x to the 12th power. How do we get it? Well, we know that any time we have a base with an exponent raised to a power, we multiply the exponent times the power. So we have a negative times a negative is positive. 3 times 4 is 12. Okay, I'd like you to express this as a single fraction, simplified form without negative exponent. Let's suppose we have a squared b to the negative 4 c raised to the negative 3rd power. Okay. Jan.
Equals b to the 12th over a to the 6th, c cubed.
Very good. Very good. Remember, this c has an exponent of 1. Now this is property 5, I think, dealing with the laws of exponents. It says a, 2 times a negative 3 is negative 6. We have a b, negative 4 times negative 3 is positive 12. We have c, 1 times a negative 3 is negative 3. So we raised it to the power, but there's more instructions. It says write the answer without negative exponents. Well, that becomes 1 over a to the 6. B's okay. C becomes 1 over c to the 3rd, which, as Jan said, was b to the 12th over a to the 6, c to the 3rd. There you go. Same instructions. Write as a single fraction in simplified form without negative exponents. There you go.